Hello everyone, I am Ajay from the School of Mathematical Sciences, NISER, and my partner is Prateek from the same department. This video is a part of our continuous evaluation for the course CS460 Machine Learning, instructed by Dr. Subhankar Mishra of SAPS. In this video, we are going to talk about the decision tree and the concepts and the classification using Gina Impurity.
Before going into the main topic, let's see what are the contents we are going to cover here. We will start with some basic concepts about the decision tree, its characteristics by giving some examples. We will see how the classification works using a decision tree. Then we will briefly go through the pros and cons of that. After that, we go into our main topic, that is the implementation of Gini impurity. Well, of course, the Python codes are here to aid us with our task. At last, there are differences mentioned. Okay, let's start with the basic concepts. Okay, now let's have a look at the definition of the decision tree. Considering a given data set, D equals T1, T2, T3 up to Tn, where each Ti's are the average represented as Ti equals Ti1, Ti2 up to Tis, HTIs. The given data set contains S number of attributes, that is A1, A2, A3 up to AS. So here Tij is the value of Ti for the attribute Aj. Let us have M number of classes. Decision of the decision of classification tree is a tree associated with D, a data set, such that each internal node is labeled with attribute AI. Each arc is labeled with predicate, which can be applied to attribute at parent node. Each leaf node is labeled with class CJ. Okay. So a decision tree is an important data structure known to solve many computational problems. Let's have a look at the example mentioned here. We have a data set where the columns labeled as A, B, and C are the attributes which take binary values or zeros and ones, basically. A column labeled as F here, the right side, top extreme right, represents the class. And we have a decision tree associated with the given data set. Now let's see how this tree works. We begin the exploration of the tree from the root node, which is A in our case. It takes value 0 and 1. So we have two child nodes. Now we have two choices, B or C for this. Without the loss of generality, let us choose B. Now again, without the loss of generality, let's consider the left branch. That is, A has the value associated with it as 0 and B as a child node. Similarly, now considering B as the parent node, all we are left with is C as another child node. And similarly, we take the left branch. That is, the value associated with B is 0. After this, we have two edges from C, where when C is 0, we end up in class M0, and when C is 1, we get the class M1. As clearly depicted in our tree, that is the value 0, 0, 0, it is class M0, and 0, 0, 1, it is class M1. But on the whole, the decision tree truly represents the given data set that we have. In this specific example, we took the values in binary, but it is also possible to have continuous or categorical values. We have another example to understand the above stated in a very much better way. Suppose we have three real numbers, A, B, and C, and we want to arrange these numbers in increasing order. let's check. First, let's check whether A is smaller than B or not. Either it is true or false that A is smaller than B. So let's just say that it is true. Then we shall compare B and C. If for the question whether B is smaller than C, we get the true answer, true as an answer. We conclude that A is less than B, which is less than C. Else we will check if A is less than C. For true value, we will get A is less than C, which is less than B. Similarly, we can ask different questions, and by getting such answers, we can get the proper ordering for the given A, B, and C values. Now we will discuss about some characteristics of the decision trees. As we can see, the data set contains an array of size n. So the decision tree can be of n. In a decision tree, there are different edges, different nodes. There is a special node with no incoming edges, called the root node. All nodes are drawn with a rectangle in some rectangle boxes from which there is no outgoing edges are called terminal nodes or leaf nodes. All the remaining nodes drawn with circle ellipse here are called internal nodes. Edges of a node represent the outcome for a value of the node. In a path and node with same label is never repeated here. Okay. Here is another example. So basically depicting what I just mentioned before. The general node labeled as 1 is the root node. The nodes labeled as 3, that is the S, M, and T are the leaf nodes. And the remaining nodes labeled as 2, that is height, is the internal nodes. So they are the internal nodes. So F and M, the constraints on edge, that is edge less than 1.8, and others are the values of the edges. Now the question is whether for a given data set we have a unique decision tree or not. Let's consider another example to understand this as well. Here we have 3 attributes: refund, marital status, taxable income, namely, and 2 classes: cheated or not cheated. The first decision tree model takes refund as the root node and builds the tree accordingly. So, but the second model here takes marital status as the root node. So we can clearly check that both the decision trees satisfy the given training data set. So we conclude that for one data set, we can have more than one decision trees. That is, decision trees not unique, as different ordering of internal nodes can give different decision trees. Yeah. So let's talk about the classification task involving the decision tree. So our decision tree helps us to classify data. Internal nodes are some attributes, edges are the values of attributes, and the external nodes are the outcome of classification. Such a classification is, in fact, made by posing question, starting from the root node to each terminal node. In this part, we will see how the classification task works using decision trees. Given a training data set, we will create a data set, a decision tree model by providing required tree induction algorithm. The model will introduce the resulting class for the new test data. We will understand this better with our example as well. In the example, we have the training data set and the corresponding decision tree considering the declared 40 leaders. In the example given here, we have the training data set and the corresponding decision tree. Consider the test data. We will start from root node. It has value refund. So we will go to the refund attribute. the test stage. The value of the refund is low. So from the decision tree, we will follow the edge labeled as no. We reached at the internal matter stages. And now in the test data, the matter status attribute has value as merit, as we will follow the merit edge in the decision tree and get to the class as not cheating. We can see that we have not used the attribute taxable income as we reach the leaf node and we stop there. But let's assume the attribute of matter status is the post. Then by following consistent edges, we will get the class as cheated or tax income equals for tax income equals 90K. Okay. Here we present another example. We have the given training data set, the learned decision model, and the test data. Follow the values of data and decision tree accordingly. And outlook equals rainy and comes to windy attribute. Windy equals true, so the result is now following the decision tree, so gives us this and completely makes sense.
Okay, so we know that every machine learning algorithm has its some advantages and disadvantages. Let's talk about what are the advantages for this model. That is, why should we use decision tree? Because it is easy to interpret. For example, if the outlook is sunny and the humidity is high, from the decision tree, we can say that it is the answer is no. That is, we can't retain this or whatever. And the second one is it performs feature selection. The top few nodes on which the tree is split are essentially the most important variables within the dataset, and the feature selection is completed automatically. Now let's talk about what are the disadvantages for the decision tree. Generally, they're unstable. By unstable, we mean that a small change in the dataset can lead to a large change in the structure of the optimal decision tree. They are often relatively inaccurate. Many other predictors perform better with a similar data. This can be remedied by replacing a single decision tree with a random forest of decision trees. But a random forest is not as easy to interpret as a single decision tree. Again, for data including categorical variables with different numbers of labels, information gained in the decision tree is biased towards those attributes with more labels. Also, the calculation can be very complex, particularly if many values are uncertain or if many outcomes are linked. Now it's time to move into our next topic. We will learn how we can create a classification tree using Gina Impurity. So, what is CART? It refers to the classification and regression trees. A classification and regression tree is a predictive algorithm used in the machine learning. It explains how a target variable value can be predicted based on the other values. It is a decision tree where each fork is split in a predictor variable and each node at the end has a prediction for the target. The CART algorithm is an important decision tree algorithm that lies at the foundation of machine learning. Moreover, it is also the basis for the other powerful machine learning algorithms like back decision trees, random forest, and boosted decision trees. So here The Gini index is used as a splitting tool for the CART algorithm consisting of discrete and continuous data. We need a way to quantitatively evaluate how good a split is. This is where the Gini impurity matrix comes in. Let's suppose we randomly pick a data point in our dataset, then randomly classify it according to the class distribution in the dataset. Then, what is the probability we classify the data point incorrectly? So, the answer to the question is the Gini impurity. So, in the dataset S containing n classes, the Gini impurity S is defined as 1 minus summation of j equal to 1 to n of pj square. So, what is the pj? Pj is the probability of picking a data point within the class J. So, Gini S measures the impurity of the whole dataset S. So, the smallest value of Gini S is 0, which takes when all the classification are same. And this is the best possible impurity. The node with uniform class distribution has the highest impurity. An attribute with smallest in impurity is selected for the splitting. Now let's consider the example to understand this. Suppose we have two features, outlook and temperature, and we want to know whether we want to play a game or not. So here we have two classes. One is not play and another is play. Not play is represented as blue dot and play is represented as yellow cross. And for the attribute outlook, we have two values. One is sunny and one is rain. Here from the figure 1, we can see the for the sunny we have 3 data points and all the 3 are for play. And for rain we have only one data point, that is not play. So when we calculate the Gini impurity of sunny, it will be 1 minus 3 by 3 square minus 0 by 3 square. That will give us the Gini impurity for the sunny. So similarly for rain, we have total 1 value and the Gini impurity of rain will be 1 minus 1 by 1 square and 0 for play, 0 by 1 square. Then we will calculate Gini impurity of the outlook. So Gini impurity of outlook will be the weighted Gini impurity. That is, we have 3 sunny data points and 1 data point for rain. So overall we have 4 data points. So 3 by 4 into the Gini impurity of sunny plus 1 by 4 into Gini impurity of rain. So the Gini impurity of outlook will be 0. So which is the smallest one? So this is the best threshold. Now let's calculate the Gini impurity for temperature. From this figure, we can see we have two values for the attribute temperature, one is hot and one is cold. Hot has two values, one is play, one is not play, and cold, one is play, one is not. So the Gini impurity of hot will be 1 minus 1 by 2 square and 1 by minus 1 by 1 by 2 square. And the Gini impurity of cold will be the same. So the weighted Gini impurity for calculating the Gini impurity of temperature will be 2 by 4 which meaning impurity of hot plus 2 by 4 into Gini impurity of cold that is equal to 1 by 2. So for this case this is the worst threshold. So as the Gini of outlook is the best one, so we will choose outlook attribute to split the data set. Now let's consider another example. So here we have 5 data points, 5 days. So the outlook is sunny and rain, temperature is hot, mild, and cold. Before this one, we have only hot and cold. Now we have mild also. And set plus yes or no. So we will create a table for outlook. So when the outlook is sunny, so we have 2 no's and 2 yes. The number of 2, number is 4. So total number of sunny is 4. And total number of rain will reach 1. That is only yes. Similarly for temperature, for hot we have 1 no and 1 yes. For mild we have 1 no, 0 yes. For cold, 0 no, 2 yes. So now we will calculate the Gini impurity of sun. That will be 2 1 minus 2 divided by 4 square minus 2 divided by 4 square. That is 4 by 8. And Gini impurity of 1 minus 0 by 1 square minus 1 by 1 square, that is 0. So the weighted Gini impurity of outlook equal to 4 by 5 into Gini impurity 4 by 8 plus 1 by 5 into Gini impurity 0. So that will be 4 by 10. Now from this data set, let's make another table that is hot and mild and cold, mild and cold and hot. So for this one, 1 plus 1, 2 rows and 1 plus 1 is and cold as well. So here the Gini impurity of hot and mild is 1 minus 2 by 3 square minus 1 by 3 square. It is 4 by 9. And Gini impurity of cold equal to 1 minus 0 by 2 square minus 2 by 2 square equal to 0. So similarly, the Gini temperature is 3 by 5 into Gini impurity 4 by 9, 2 by 5 into Gini impurity of this one 0. So the Gini impurity temperature is 4 by 5. Similarly here, the hot one is 1 no 1 yes, mild cold is 1 plus 0 1 no, 2 plus 0 2 yes. So Gini impurity of hot 1 by 1 minus 1 by 2 whole square minus 1 by 2 whole square equal to 1 by 2. Gini impurity of cold and mild 1 by 1 minus 1 by 1 minus 1 by 3 square minus 2 by 3 square equal to 4 by 9. And Gini into temperature equal to 2 by 5 into 1 by 2 plus 3 by 5 into 4 by 9 equal to 7 by 50. So now let's compare the Gini impurity. So, as you can see, so now we calculate from these two values, which is the least one. Clearly, it is the 4 by 15 one. So Gini impurity of temperature will be 4 by 15. Now we will compare this one with this one. So Gini impurity of outlook is more than Gini impurity of temperature. So we will take this one as the splitting node. So we will choose the smallest one to be the least node. That will be the temperature. The temperature. Then in within the temperature, hot and cold will be our next grid. So let's see how the tree will look like. So this will be our the decision tree, the given data set. So also temperature is the least one with the least general variability. So that will be our root node from which we have cold and hot and cold. It was the least one within the temperature. Then for cold, we have yes, there are two cold. For this, we have two yes, that is here. And for hot and light, we have three values. As you can see, the three values. And the Gini value for the hot and light is 4 by 9. So we will compare it with the Gini value of output for those three values. So for these three values, we have two no and one yes. We can calculate the generality of sunny, and there is no rain, so that is 0. So generality of sunny is generality of the outlook for those three data sets. So that will be equal to 4 by 9. We can calculate similarly. So here the generality for those three values of the outlook is not less than the generality of this hot and light. So here we terminate our decision. This will be the weaker decision tree for the given data set. Now let's look into our code. So as the first step, we will import all the required libraries. And so before moving forward, let's say if we have the data set T, which is split on the attribute A, and A has two subsets, D1, D2 of size N1 and N2. So the generality of the attribute A can be written as N1 by N into generality of D1 plus N2 by N, generality of D2 plus N is the total number N1 plus N2. That is what we did here. So with the that is the voted in impurity. So when the training a decision tree, the attribute that provides the smallest gene A is using to split the nodes. So we have imported our libraries. Now, for a 2-class problem, the graph of the impurity measures as a function of the probability of the first class. That is, let's say we have two classes, yes or no, and x is the probability of the data belonging to yes class. So this will be our y value will be our the Gini impurity. We can plot xy. So this will be looked like out the plot. Here we can see that the maximum Gini impurity value is 0.5 for the 2-class Gini impurity, and the minimum value is 0. So here it is the graph of the Gini impurity. If the probability is 0, that is the data belongs to no class, then we have Gini impurity 0 and the data belongs to yes class, then impurity is also 0. That is, the genuine impurity is minimum for the homogeneous sample that is being probability equal to 0 or probability equal to 1. Now, let's consider the data set with two class, that is no and yes. The class name is default, and there are different attributes: age, income, student, predicted. We will predict whether a person will default on their credit card or not. So then we created the data using array and changing it to the data frame. Now the step one is to calculate the Gini impurity. So here this calculates the sum as it has only two classes. So we can use this formula to get the sum, and the Gini impurity is the 1 minus sum. So return Gini, that will give the Gini impurity when the attribute is passed. So here we can check the number of samples in each class. It is for yes we have 9 classes, for no we have 5 classes, and the class name is default. So Gini impurity of the whole data set is 0.45. We have calculated this using this. Now the step 2 is we have to calculate the Gini impurity for individual attributes. For this, we will split the total data set according to their attributes. So again, we can here the Gini impurity equal to Gini A plus the weighted average into the Gini impurity of those attributes. So this will give the Gini impurity of the particular attribute. Now we have to find the Gini impurity for the different attributes. That is, in the impurity of age is 0.343, in the impurity of income is 0.440, for student is 0.367, and 20 is 0.429. Next we will check which one is the lowest one. So the minimum value from the Gini attributes is 0.343. So the corresponding attribute is age. So the minimum Gini impurity value with attribute age will be our splitting. So let's summarize what we have done. We have calculated all the weighted average weighted Gini impurity values. We have selected the best threshold. Then we know that if each leaf node contains data sample from the same class, or this some preset threshold has been certified, then we will stop. Otherwise, we will continue splitting. Then we will use an independent test set to reduce the region. And the computational complexity for this is low for both evaluation and the treatment. Here are some references we have used for this video. That's all for from side. Thank you.